number 1 is 12. Okay, now here's the thing. You have to clearly label the things. If this is F, then F prime is this guy over here. F double prime is this guy over here, and F triple prime, or as some of you might be tempted to say, F prime 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 is going to be 12. And if you went one more derivative, we would get
F quadruple prime.
F prime 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 prime, and we would get as an answer. This guy here is 12.
0.
A constant. The derivative of a constant is
0.
0. Good. All right, number 2, d dx, right? This is another one of the notations for derivative. The derivative is going to be 15x to the 4th plus 60x cubed minus 2. Now I've got to plug in -1. Do that correctly, and you're going to get -47. All right, let's go a little bit faster. Number 3, now it's just a matter of, oh, square root of t, that's really t to the half. 1 over t is t to the -1. Something I want to be careful about is linking things. When you use the equal sign, David, where's your homework? Over here. You gonna check it out? Yeah. Okay. Thanks, David. Be careful with the equal sign. Some of you guys are linking things together that are not true. The square root of t, is that equal to t to the half? Yes. 1 over t is equal to t to the -1. It's okay to use the equal sign here. Some of you, though, are saying that this equals this guy down here. This is the derivative. They're not equal to each other. These are different functions. Be careful with the equal sign. 1/2 t to the -1 over 2. You can write it as 1 over 2 square roots of t minus 1 over t squared. I love it. Plug stuff in, you're going to get -1/2. All right, number 4. I think we're still struggling in the world of the tangent line. You've got a function. You're going to take the derivative. Hopefully the derivative not too bad. If you're going to write the equation of a tangent line, you need 2 things. Those 2 things always. Point and slope. You get the slope by using the derivative. The derivative at 1 is equal to 25 over 4. You get the coordinates for the point by using the original function. F of 1 is equal to 16. Put all this together, L of x, the equation of my tangent line, equals slope times x minus 1 plus 16. If you're getting it wrong, give yourself some feedback. Let's fix it. All right, let's jump ahead over here. The piecewise function. I'm going to keep beating piecewise functions into you all, and differentiability. So if you're going to check differentiability at x equals -1, first, show me continuity. You have to show me f of -1. You have to show me limit as x approaches -1 from the left. You have to show me limit as x approaches -1 from the right. Congratulations, f is continuous. You have to show me continuity first, David, before we start having conversations about derivatives. You take limit as x approaches -1 from the left of your derivative, you get 9. Limit as x approaches -1 from the right of your derivative, you get -1. The only conclusion you can draw now?
Not differentiable at x equals
F of x is not differentiable at x equals -1. When you check differentiability at x equals +1, it's a different point, so we start with continuity again. Congratulations, you're continuous. You then go and you check your derivatives. Derivative from the left is -1. Derivative from the right is -1. My conclusion, f prime of 1 exists. F is differentiable at x equals 1. I was going to say, like, looking at the homework assignment that you guys turned in yesterday, proving differentiability, you guys seem to be doing a good job, considering we did like 30 minutes on Wednesday. All right, round 3, a little bit of number line action. I want to know where f is decreasing. That means f prime is negative. We take the derivative, set the derivative equal to 0, build your number line. Is everybody okay with the number line? 0 and 3, we're going negative, negative, positive. I'm going to do my test values, right? You don't even have to show me the test values. If you can do this in your head, please do. F is decreasing, negative infinity to 0, 0 to 3. It's less.
When doing the number line test, it's for the derivative, right?
Right, but why are we looking at the first derivative here? There's a reason.
Because we're trying to see where f is
Because we're looking at where f is decreasing when f prime is negative.
Right.
So that's why it's a number line for f prime right now.
So you can't use that as the actual proving point, remember?
The number line is a way that you organize your work. It's not the final answer. You're going to have to give me a statement that says f is decreasing, f prime is negative, here's where.
So it's not notation, it's just a way of working.
It's a way to organize your thoughts. All right, next one. Now I'm asking about concavity. Concave up. Second derivative has to be positive. Take one derivative. If somebody can get that, that'd be great. Take another derivative. Set it equal to 0. Like I'm giving you guys polynomials right now. We're just in polynomial calculus. Better stuff is coming. X equals 0 and x equals 2 go on the number line. This is the number line for f double prime. Positive, negative, positive. F is concave up on these two intervals because f double prime is positive. Is it pretty okay? All right. And the last one. I'm really interested to see who's got this one right. If f is both decreasing and concave up, then it means two things are true. F prime has to be negative, and at the same time, f double prime is positive. It's got to be both. You need values of x that do both things at the same time. So what I did is I said, okay, let me make my number line for f prime and my number line for f double prime. Are there values of x where f prime is negative and at the same time f double prime is positive? Well, where does that happen? F prime negative, f double prime positive. Isn't that true up until we get to x equals 0? So like here, I don't like it. What about from 0 until the next important point? 2. Do I like this one? Yeah. Look at what I want. I want f prime negative, f double prime positive. If I look just on this subinterval, f prime is negative, but f double prime is negative. Do I want this interval?
No.
Get rid of it then. The next place to check, from 2 until you get to 3. From 2 to 3, f prime is negative, and f double prime is positive. I want that one. And on this last interval, they're both positive. I don't want that one. Right, so I want from negative infinity to 0, and I want from 2 to 3. We did nothing to fully prepare you for this one yesterday. I was interested mostly in seeing what you could do last night. Give yourself some feedback. I'm not going to pick this up for a grade. I have so many grades in my grade book already for you all. Well, not for the friends at North Central, sorry. But everybody's good? All right, so you can put that away. Aaron. And more stuff. More exciting stuff. Always going to push without thinking. I'm a pusher. All right, so let's see. For the friends here at Southwest, tonight's homework is, it says assignment for lesson 26 in the problem set. I think that's what it says. Yeah.
The next page.
Right, it's a bunch of multiple choice questions. Now here's the thing. You're going to look at this and be like, oh, there's 6 multiple choice questions. Flip the page. Right, and then you're going to see another couple there, and what does it say? Like bonus questions, challenge questions? Translate that into, if you're in BC, you must do those. Bonus! Hooray! Okay.
Oh, that's what the V stands for.
Right, that is what the V stands for. Because I said so. Exactly, bonus challenge. Now, the astute student is going to look at those 3 questions on the back and be like, hey, wait a minute. You already asked me those 3 questions on the front. Indeed, I did. On the front, though, the instructions say calculator active. On the back, calculator inactive. I want you to have your calculator skills, but I also want you to have your number line skills. Okay? All right, good enough. All right, let's earn some more life savers. Apparently the kids in North Central really like life savers yesterday. All right, so you and a partner, it does not matter to me who you want to work with, you have 3 minutes to fill in these blanks, as many as you possibly can. I'll take attendance, I'll talk to Polymon about test corrections. Test corrections. And the test that you had Mom sign.
Oh, Vale.
She signed it.
Was she awake when she signed it, Polymon?
Yes.
Okay.
There it is.
Alright.
And the corrections,
Where are we?
they're in the other one.
Oh, that makes sense.
21.
Okay.
I'm still rewriting those.
I appreciate it.
Let's get to work. We're on the stage here. So, right now.
There are a couple of these things that we've not talked about yet.
Is this like the graph you looked at yesterday? Like when you say that this is increasing and the derivative is positive?
Yes.
He's basically asking like if the graph is increasing and the derivative.
This way.
Just so that you guys know, if anybody wants their calculators engraved, we're going to be doing that Monday during lunch. Okay, but I think it's the first high school lunch period. Do you guys have that lunch or is it the second period? So what I'll do on Monday is if you want your calculator engraved, I'll say give it to me with like a post-it note on it, and I'll get them engraved. On Monday, I'm going to be engraving graphic calculators. So get them, but not during class because I would lose my mind if I can't get it. Okay. But I'm only available to do it during the first lunch. You guys have separate lunches. So what I'll do on Monday is if you want to get your calculator engraved, I'll say like right now, post-it note, what are your initials and like your number. Give it to me. So what I can do is in class on Monday, I'll just ask you like where to put it on post-it note, your initials and your number. I'm gonna grade it for you guys.
No, isn't it weird? Isn't it vertical?
That's fine. That's totally okay.
And then,
Had a phone. Had a phone.
and then we'll
Phone
move,
over there.
and because now we establish this,
Then F prime of X
Sorry,
is
where are
where F is one.
for 4, F prime of X is
So wherever F is
All right, let's do it. Some of these are easy and obvious. Others we haven't really talked about yet. So let's get some hands on this. What do you know? I'll take anything from anybody. David, then you're frozen.
For if f of x is increasing at x equals c, then f prime is greater than 0.
Okay, but where is f prime greater than 0?
X equals
At x equals c. I want you to be really specific. All right, Aaron, give me another one. And you can pick any of these. It doesn't have to be the next one.
If f of x is decreasing at x equals c, then f prime of x is negative at x equals c.
Way to push yourself there. Make David do all the work. Aaron, here you go. Next, I'll take anything from anybody. What else do you know? Carmen.
If f of x has a vertical tangent at x equals c, then f prime of x has a vertical asymptote.
F prime of x has a what?
vertical asymptote.
Vertical asymptote at x equals c. And just so that we're clear, when I say vertical tangent line, we're talking about a tangent line that is perfectly vertical, not vertical asymptote. Hold on.
If f of x has a cusp point.
If f of x has a cusp point, can you guys remind me what a cusp point looks like? I sometimes forget. Right, cusp point. It doesn't have to be like this. It doesn't have to be super sharp. Cusp point could look like that. Cusp point could look like that. Cusp point could look like that.Ese are all cusp points. If I have a cusp point, then the thing that I know?
Then f prime of x does not exist.
F prime of x does not exist. Tell me where?
At x equals c.
At x equals c. Nice. All right. Any other ones that we know for sure? Stephen?
If f of x has a horizontal tangent at x.
Ooh, a horizontal tangent line. What does that look like? Horizontal tangent line, we're just going like this, right? Keep it easy. What do you know for sure?
Then f prime of x equals 0 at x equals c.
F prime of x equals 0 at x equals c. All right. All right, what else? What else? Celeste, you want to take one?
Okay, if f of x has a vertical asymptote at x equals c, then f prime of x does not exist.
For sure, if you have a vertical asymptote, right, we're thinking about like this thing here. Think about vertical asymptote behavior. Let me draw it off on the side. Here's x equals c. What happens is your graph has to do something like that, or maybe something like that, right? Or maybe it's this and that, right? Lots of combinations. What's the derivative at x equals c? Doesn't exist. Even better, even stronger, there's something else you can tell me.
There's a vertical tangent line at x equals c.
Not a vertical tangent line, because your graph doesn't even exist at x equals c. Think about your tangent lines. What's happening to those tangent lines as you get closer? They're getting steeper. The slopes are getting like closer to like positive infinity or down towards negative infinity. If f has a vertical asymptote, then f prime has a vertical asymptote as well. Vertical asymptotes, once you catch one, it's with you forever in all the derivatives, because if you're getting close to a vertical asymptote, you get steeper, 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 steeper. This one I put a little star next to. This one's a tricky one. Vertical asymptote, yeah. All right, horizontal asymptote. You guys know about behavior near a horizontal asymptote. Horizontal asymptotes look like that. What happens with the derivative?
It's closer to 0.
But even more specific, you're right, there's going to be a horizontal asymptote, but in a very specific way. What's happening to the slope? It's approaching 0. So if your graph has a horizontal asymptote, not at, but as x approaches infinity, then f prime of x is going to approach 0 as x approaches infinity. All right, we're going to come back to critical point in a little bit. Relative max. Can you guys draw a relative max for me? What would that look like? Relative max. Think about a relative max. Okay, what I'm seeing is a lot of folks saying relative max looks like that. True. Relative max also can look like that, right? Now here's the thing. A lot of folks say if I have a relative max, then the derivative has to be 0. Is that always true though?
No.
Right, that's not going to work over here. What is true is what happens, like if you're saying here's x equals c and here's x equals c, what is true is what happens as you get close to c. You have positive slope over here, negative slope over here. Does that work over here? Positive slope, negative slope. What's true with a relative maximum is that f prime of x makes a change, delta for change, from positive to negative at x equals c. Now that we've got relative max under control,
probably get relative min under control for free. Relative minimum, we're looking at like something that looks like this guy here, or possibly something sharp. Avoid the temptation to just think about this kind, because this kind you're going to say derivatives equal to 0. I've got to think about this guy as well. The one thing that's true if I think about slopes is that f prime of x makes a change from negative to positive at x equals c. And I don't know that anybody knows this word from pre-calc.
Saddle point?
Saddle point. Anybody know saddle point? Let me show you what a saddle point looks like. A saddle point looks something like that. Not a maximum, not a minimum. This is a saddle point. And it's not even that you're approaching 0 here.
It is.
It is 0. I think it's called a saddle point, and North Central folks, who knows? I always think of a horse and putting a saddle on the horse. Right, this is where if this graph was a horse, I'd put the saddle here, where it's nice and like flat. If that analogy doesn't work for you, too bad. All right, so this is a saddle point. What's true at a saddle point is that f prime of x equals 0 at x equals c, but f prime of x does not change sign. Does not change sign. So you're just saying, like, my graph was increasing, it flattened out, and it continued to increase. Or my graph was decreasing, flattened out, continued to decrease. And this last one, critical point, I think is a brand new word for you guys. A critical point just means that f prime of x equals 0, or f prime of x is undefined. Critical points, your derivative is equal to 0, or your derivative is undefined. This is pretty much all the things that you guys need to know for now. If you're a flashcard kind of person, I would go and do that. Just so that you know, you might even want to write this down. Monday when you guys come in, there's going to be a short quiz on all of these. So if there's something you're not sure about, you definitely want to ask me now. Okay. I must have done an excellent job of that. All right, so let's put, all we're going to do for the rest of this period is put all these things into practice and grow some calculator skills. All right, so here's what I want you guys to do. We're going to go to page 22. And what you've got is you've got a couple of graphs here. And I'm going to ask you to sketch by hand what the derivative graphs must look like. What I'm going to ask you to do, though, is not just give it a sketch, but I want you to be ready to talk to me about why the graph of your derivative has to look the way that it does. You're going to use information from the graph of f to make the graph of f prime. You're going to use information about the graph of m to make the graph of m prime. You got a couple minutes, great opportunity to use your notes, talk to each other. We're going to pretty this sucker up in just a few minutes. graph, what are the things you know for sure? So you might want to keep in mind right over here, that's 0. If I were to draw a tangent line there, the tangent line would be horizontal. If this graph has a horizontal tangent line, what has to be true about the derivative? That's right, go back. Right, so that means that at x equals 0, I have a horizontal tangent line, which means that here at x equals 0, I'm going to have a root. Derivative is equal to 0, so now I have a 1 times. Now using that, we also, there's another horizontal tangent line, right? Negative 1 there. So at x equals, what is that? 2? Nice. All right, friends, let's pull this together. I think it's going to be helpful when you're going back and looking at this later if you're using markers to like mark this up. There's all sorts of pretty colors in there. Ah, perfect timing. All right, now here's the thing. I do not want anybody to tell me what the entire graph looks like. I'm just looking for evidence, things that you know. You looked at this graph, and what did you know for sure about f prime? Celeste, then you're frozen for a little bit.
There is a root at x equals 0 and at x equals 2.
Now, I want to push you to be a little bit more specific. What I heard you say is there is a root at x equals 0 and x equals 2. This is what you have to be specific. Name the function. Which function has a root?
Oh, f prime of x.
F prime of x has the root because? What's happening up here?
There are two courses.
David, thank you for being there for her. I've got a horizontal tangent line here. I've got a horizontal tangent line here. Because my graph of f has horizontal tangent lines at 0 and 2, I can come down to f prime, and what I can say here, I'm going to have roots at 0 and 2. Nice, you're frozen for a little bit. What else? What else? Andrew, what are your thoughts back there? Anything else that you know about the graph of f and what it tells you about f prime?
Minimum.
Lewis started smiling as soon as you said the word it. He knew I was going to get you.
F prime of x has a minimum at -3.
At -3. How did you come up with that?
I plugged it in.
You plugged it in. All right, let me help you out here. Andrew, what do you know about the graph of f over here?
Increasing.
F is increasing, so when I come down to f prime must be,
Positive.
remember, still frozen. Andrew? F is increasing, f prime is
Positive.
positive. That's the only thing I can say about f prime. F prime is positive, meaning above the x-axis. So I have to be above the x-axis whenever f is increasing. What's that going to look like? If I'm going to hit that root, I'm going to have to do something like that. Right? This is f increasing, this is f prime positive. Other things. Other things that you know for sure. Alea, what else do you know for sure?
From f at x from x equals 0 to
X equals 0.
x equals 2 if f is decreasing, therefore
F is decreasing, therefore, what a good word.
f prime should be negative.
F prime has to be negative. Now you might say, oh, negative, like, okay, la 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 la. But look what happens when you get to x equals 2, f stops decreasing. So f prime stops being negative and has to hit that root. So it's going to look something like that. This is f prime negative. You can also say, okay, f is increasing over here. If f is increasing, what do we know about f prime? F prime has to be positive. Now, I bet most of you are not surprised that the graph looks this way. Why are we not surprised? Why are you not surprised? You started with x cubed minus 3x squared plus 2, and your graph has this familiar shape. Stephen, why are you not surprised?
Because for the beginning of the derivative x squared, so that means it must be
Right, if you're using power rule thoughts here, the degree goes down. You started with cubic and you ended with quadratic. This should hopefully make some sense over here. Now, maybe what you wanted to say is, hey, f has what? Has a max at x equals 0. Well, what's true about f prime? If f has a max, then f prime? Don't tell me 0.
Oh.
Because those people are thinking this kind of maximum. Look at those notes. There's one thing you know for sure. At a max, what does f prime do for sure, Palomon? Check your notes if you need to. Tell me about f prime. F has a relative max. F prime, what's it doing? Changing. Check your notes. You're killing me. You're killing me. F has a relative max. F prime makes it. Myra, thank you. F has a relative max. Polymon, F prime, how is it changing? From positive to negative. Yes, thank you. F prime made a change from positive to negative. F has a relative min. Golly, I'm too good looking to work this hard. If F has a relative min, F prime makes a change from negative to positive. We did that? All right, I want to do this one really quickly. We know that M, be careful here, M is decreasing, so M prime? M prime has to be?
Negative.
Negative, but even more specific, I think you guys can tell me what the slope is here. Right, the slope here is?
Ooh.
Ooh.
-1.
-1. So this is M prime equal to -1. This guy over here, M is increasing. M prime?
1.
+1. Now be careful, because some folks might forget that there's something special happening over here. You've got a cusp point. What's true about the derivative? If M has a derivative, M prime cannot exist. So don't define these points. You know how to handle that. Open circles. Right? Graph of the absolute value of x, graph of its derivative, and I think most of you guys know this graph now.
Oh, you want to say?
Yeah.
Oh.
Absolute value of x over x.
This should be absolute value of x over x. Okay? Now let's check. Palomon, this one's coming right back to you. Be ready for it. Yes, this is a cusp point, but this guy here is also a relative minimum. What must be true if you have a relative minimum, Palomon? Palomon, don't waste my time. You got a relative minimum. Tell me about the derivative.
That's really mean that f approaches negative to positive.
No, that's not approaches. That triangle means changes. Is the derivative changing from negative to positive?
Yes.
Hold on, I don't think I get all the brains here. Is the derivative changing from negative to positive?
Yes.
Right, now it's not changing from negative to positive and being equal to 0 in between. It's a jump discontinuity. You can have change from negative to positive this way. You can have change from negative to positive this way. You gotta be careful. Everybody okay? Here come the calculator skills. All right, David, you gonna drive for me? All right, Palomon. All right, what I want you guys to do on your calculator, graph f of x, please. The f of x that we just did.
You talk all the time.
I'm going to shove this dirty rag in your mouth.
Oh,
That's why.
All right, x cubed minus 3x squared plus 2. Okay, we've got the graph. Not a surprise, this is exactly the graph you have on your paper. I want to show you how your calculator can graph the derivative. So hit the tab button so that you get F2. Okay, here's what we're going to do. On your calculator, you need to hit the button that's near the Bible. Here's the Bible. The button near the Bible.
Oh, the boxes.
Right? There's something that should be screaming derivative, David. Right? It's in that second row. It's this guy here. Now here's what you need to do. You need to say this is derivative with respect to x. So d dx. What are we taking the derivative of? You have a choice here. You can retype the function, the x cubed minus 3x squared plus 2. Or if you really want to get clever, f1. But I think you have to do f1 and you have to say of x. And now hit enter. And this should be exactly the graph that we just sketched. And what I love about the TI Inspire, what I love, you get the different colors, right? All the things that we know are matching up. Is everybody good at the graph? All right, check to see if your calculator can handle the graph of the absolute value. Okay, derivatives are good.
Do I delete this?
Giselle?
And then
Yeah, you can delete it. I just want you guys to make sure you get the skill.
we're gonna find.
Is everybody able to get a good graph? Yeah, and that's why we're doing this one. Okay, David, menu, action, delete all. Okay. The absolute value bars live over here in the button near the Bible. So absolute value of x. Enter. Okay, now do the second one. Everybody okay? We totally got this under control? Alright, here's what I want you to do. If you guys have this under control, this is what you need to do. I want to push the thinking a little bit more. David, you can rejoin the rest of us. Thank you so much for your service to God and country. Okay, on page 23, there are 3 different graphs. Here's what I want you to do. I want you to start graphing by hand. I want to hear the conversations. I want to hear things like, hey, I noticed that this graph has a horizontal tangent line over here, so the derivative is going to have a root. Sketch it by hand first, then check it on the calculator. We'll talk in a couple minutes.
Okay, there is, well, the derivative of g of x equals 4x minus x. There is a relative maximum at x equals 0, and there are 2 relative minimums.
All right, this is a very verbal, good-looking group over here. Is it all right if I have the North Central friends join you? And Aaron, if you stay right there, we don't even know that Palymon exists in this picture. And for the friends at North Central, Celeste is on the left, Myra is straight in front of you, the good-looking guy on your right is Aaron Hawthorne.
Where?
And the funny-looking guy in the way back is Palymon Soto.
Okay, I'm gonna say that's 3.2.
That's about right.
Negative 3.2. Because I don't know. Okay, at negative 1.5 there is a root, and at positive 1.5 that's, yeah, yes, we just put that stuff. The function. The derivative.
Well, zero.
He says not the same. So she says the stuff.
Am I doing this right?
Yeah.
Pretty the roots.
Yeah. Oh, and there is another room.
Oh,
Yeah, everything.
What's the one of
he's saying he's doing this like how I did it right here. Look.
Oh, from negative.
Yeah, like look.
What I guess negative
I
infinity
highlighted the
to.
different parts. Like it's decreasing over here, and it's increasing right there. He's doing that right now.
Okay.
He's like, he's not worrying about the roots.
That's the copy. But his looks nice on it. Right, when I'm gonna use really quickly that, I'm gonna look to see where you have roots.
Shouldn't say that.
Do you have roots every time that there's horizontal?
I'm giving him credit, so it's okay.
I'm gonna look to see if this function is
I gave him
decreasing or
credit.
negative.
I got
What?
the idea from
I'm not gonna worry about how far down does this
Yeah,
part go.
I
I'll worry about that.
Just kidding. I don't cheat on it. I don't cheat on this.
No, I'm giving credit to who I cheered on. So it's okay.
Focus. And remember, I have video evidence now to share with all of your parents
What parents?
and college admissions officers.
Oh, crap. You pen if you're listening. Nah.
I'm a good girl.
Where's the? Wait, how many roots do you have marked? How many roots do you have marked?
3
Where's your third?
at 0.
Oh, right. Wait. Oh. Ha.
Because at 0, at x equals 0, there's a maximum. So it changes from positive to negative.
I'm sorry, what?
I don't think that makes sense though. How they
F of x changes from positive.
G of X.
F prime of x.
G prime.
Oh, G prime. Thank you.
Save
There
them.
is a reason I want you guys to get practice with the words and the writing, because it's gonna be this big.
Really?
Yeah, man.
It's gonna be like this.
Right, so now that you've got it sketched, let's check it on the calculator. Let's make sure you actually are not lying to yourself.
I'm not.
You have some
So wait, doesn't that mean it's
disappointment.
going to change from positive to negative?
Yeah, that one works.
Huh?
At the
Well,
minimum,
I'll
right?
for
It's
sure.
also going to change from positive.
So
It's going to
how
change
about
from
done?
negative to positive. Because it's a
Oh,
minimum.
right.
Are you okay?
I just did something for myself.
He said you
Because usually we're asking each other stuff.
So start my house.
I don't know. I'm asking for help.
You get it.
Not here.
And I'm always asking for the easy question.
I don't know why, but I wrote.
I need solutions. I need solutions.
I was like, you're missing something.
It's the story of my life.
Those are like silly mistakes.
It's the story of my life. I need solutions.
I've got the keys.
Oh.
No, you know the song. You know the song.
Is that negative 2 you have it going?
All right.
No, what? 1.5. There's another rule.
Right here? Oh.
At x equals.
All right, friends.
Right here. Yeah.
Read them and wait. From what I saw walking around, everybody was fine with the first graph.
Yeah.
Second graph going pretty well. Now I'm curious, does anybody recognize the second graph?
Sine.
Cosine.
Cosine of x?
I mean, yeah.
The original graph over here,
Sine.
sine of x?
Yeah.
The graph of the derivative, cosine of x? Maybe that's a thing. Who knows? We'll figure it out. All right, now this graph over here, I saw some mistakes. Things that we know for sure about the top graph. Top graph has a horizontal, no. The top graph has no roots.
I mean, hey,
The top graph has a horizontal tangent line. So the derivative
has a root.
has a root at x equals 0. I can say top graph is decreasing. So the derivative has to be negative. The top graph is increasing over here, so the derivative is positive. Now the most popular wrong thing that I'm seeing is like, graph is, 2 hands, okay. That the graph is positive, 0, negative. What's happening is you're not paying attention to the important part, which is the ends of the graph. What's happening at the ends of the graph?
Approaching 0.
The ends of the graph, they're approaching 0 because you have horizontal asymptotes. Think about your tangent line. Your tangent lines are getting flatter, 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 flatter. They're approaching 0. Your derivative has to approach 0. So when you pull it all together, you need to have a root at 0, positive before, negative after, but then you approach 0 and approach 0, but you never get there. Much trickier than the first two. Are all the friends okay?
Yeah.
Alright, so let's see what you guys can do with this next one. I'm only going to give you time to do one and then get some calculator skills to share. I want you to show me how good I am here. Here is the graph of arctangent. And I'm a pusher. I want the derivative graph of arctan and the second derivative. We'll talk in like 3 minutes. Who will? Probably more than that Celeste?
No, Elmer.
What?
No, Myra's a good girl.
She missed one day, that's mostly.
I know it's Friday. You can take a nap in the rest of your classes.
Sketch fruit.
They have to be on the little. We're not using the card for the description.
You need your glasses. I got used to the glasses.
Like it's better for you. It's like my part. My hair is better when I do it.
What do you feel like?
Oh yeah, basically.
Well, as far as the wait, no, it's not a subtle one.
But wouldn't it have to be?
I thought
Wait.
like
Mr. Blue, it's
Thing is,
Yeah.
we'll never.
yeah.
I mean, to like increase, flatten out, and
What
increase.
is a critical point?
So a critical point just means the derivative is equal to 0.
Equal 1.
So like horizontal tangent lines,
I mean,
or undefined.
So it doesn't look like specific.
It can be a lot of different
A
things.
vertical.
So-
So critical point is a pretty like global kind of word that we're using.
I know I have to go.
Anytime that the derivative is equal to 0, or the derivative is
So
undefined,
basically
is a
approach
critical point. So think cusp points, vertical tangent line.
For the saddle.
A saddle point would work because the derivative is equal to 0 there, that's a critical point. Okay. Alright, so let's, I don't know where you're going. Well, I think long term I might know where you're going. Alright, David, can I get you back there to drive? Let's compare let's pretend you all actually graphed during that time. Okay, let's get the calculators out. On your calculator, let's graph arctan. Arctan, yes, there you go. You're gonna hit the trig button. That means arctan is the same as this tan inverse.
Oh.
Yeah, you gotta hit tab first. There you go. Trig, arctan of x. Hit enter. There's the graph of arctan. Okay, give me the graph of the derivative.
You're right.
Whoa.
Oh, you do the thing?
It's
This should be a familiar graph as well. We've seen this graph before.
Plus 1.
What graph is this? It's a parent function, Stephen.
1 over x squared plus 1.
Okay, real quick. David,
Yes.
I want you to graph the second derivative. Okay. David, you went way too fast for me. Back it up.
What?
Okay, delete all this stuff.
Okay.
Okay, button over here. Second derivative, where is it? If you just had to guess.
Next to it.
It would be the one right next to it. D squared, dx squared is our notation for second derivative. And just type f1 of x, David. f1 of x. And that new one is the second derivative. Okay? All right, I want to amend the homework just a little bit. I want you guys to finish those other two graphs that we were just looking at. Feel free to use your calculator this weekend to check it out. We'll start class on Monday by looking at your sketches. See you guys later. You're running to econ because it's like your favorite class.
Never let out. He takes me like
No!
you're an athlete. I spent century and I have to go to work. So.
I'm not, I'm in the office.
Wait,
I'm not an athlete.